All right, now we're going to start chapter 4. This is of all the chapters, this is going to be the most difficult one. It's going to start off pretty easy, but then the middle get difficult. Chapter 5 and 6 are a lot less more difficult because it just has to do with properties. Section 1 deals with polynomial functions. Okay, first off, what does a polynomial function? What does a polynomial mean? Look at the stem of these words. Poly means what? Okay, let's build up to it. What does a monomial, what does that mean? What does mono mean in Greek? Yes. No. You were close. You missed it by one. Wrong way. Mono. You ever hear mono? A mono be one-on-one. This means one term. So monomial would be something like 3 or 3x or 5x to the second. It only has one term. There's no plus or minus in there. So that means 1. A binomial. What does bi mean? What does binomial mean? Like a bicycle has how many wheels? Yes. This one has 2 terms. A binomial would be something like 3x plus 2 or 5x to the 7th minus 2x to the 3rd. It has 2 terms. A trinomial. It has 3 terms. 2x squared plus 3x minus 5 has 3 terms. A quadrinomial. Has 4 terms. So if we look at these at the basic lowest form, monomials are typically just one term, or typically they're just like constants. Binomials are linear equations. Because linear equations has the form y equals mx plus b. Trinomials are quadratic. I try not to stop till you got here. But, oh, so we're dealing with defining what polynomials are. Monomials mean it has 1 term, binomials 2. So this is a constant. Usually, not always. This is a linear. This is a quadratic. And this is a cubic. Now, why is this a cubic function? Because the largest exponent is a 3. This one's a quadratic because the largest exponent is a 2. Linear, largest exponent is a 1. So that's how we break these things down. So we could go on further because we have names for all the leading terms. Eventually it gets to be boring to memorize all those. So what we define then a polynomial, what does poly mean? Many. This is just a general term. We say polynomials because all of these are nomials. So we say polynomials. What we usually say is like, example, this would be how many terms does that have? One, two, three, four. Anything separated by plus or minus or equals is a term. So there's one term, two terms, three terms, four terms. We could say it's a quadrinomial, but what we normally say is this is a polynomial of degree 3. Remember what we refer to degrees as? What does degree mean? It has four terms. The degree the largest exponent. Good morning. So since the largest exponent is a 3, it's a polynomial of degree 3. And this one, we could define this one as a polynomial of degree 1. Because the largest exponent is 1. All right, so whenever we say polynomial, that's what we talk about is how many terms do we have in there. Now you see why this is going to be the most difficult chapter, is because up until now, we've solved monomials and binomials and trinomials. We've solved stuff like x squared plus 5x plus 6 equals 0. That's for what kind of polynomial? It's a polynomial of degree 2. It's a trinomial. Since it's a degree 2 polynomial, it's a quadratic equation. So what good is it knowing the degree? What does the degree tell us? Tells us the maximum number of solutions possible. So the degree of this one, it's a degree 2, which means we can have at most 2 solutions. What do solutions refer to? What's another name for solutions? It starts with X, ends with intercepts. Yes, X solutions are X intercepts are we call them factors, we can call them roots, we can call them a whole bunch of stuff. So when we talk about solutions of an equation, we're saying I want to know what the x-intercepts are. So we set it equal to 0. You want to take pictures of this page? There you go. I don't want to scare you. Yeah, you're welcome. So let's get back to, so with our example, we had our polynomial. Well, I'll use p since we're dealing with polynomials. X squared plus 5x plus 6. What can we find with all of these? If I give you this equation, what are all the informations you can tell me from this equation? You can tell me the zeros. You could tell me the x-intercepts. You can tell me the y-intercept. The maximum, the minimum, the domain, the range. Now, how do we find all these? Just by looking at it, can you answer any of these? I'll give you a hint. Just by looking at it, you can tell me these 4 things. It used to be. Now it's P for polynomial. Here, you want to take a picture of this real quick? There you go. Because this is, yeah, everything we just talked about. I was trying to hold off, but these guys made me hurry up and get started. You're welcome. So what can you tell me? What's the y-intercept? It is 6, but how would you put it? Because remember, the intercept is a location. What's the location? Bless you. Very good. Yes. It's 0, 6. Because the y-intercept is always the constant. You set x equal to 0, find the y-intercept, set x equal to 0, and solve for y. Now, do we have a maximum or minimum? You can only have one of these for a quadratic equation. How do you know? Very good. Remember, a polynomial, a quadratic equation, that works. Yeah. Because this first term is called the leading term. And that equals ax squared. The leading term test says this. Well, we'll use the cheat chart. Oop. Yeah. The exponent is n. So n can be even or odd. That's the degree. This is the degree of the equation. And a can be positive or negative. So in our example, what is our a? In our example here, what's a? It's 1. A is the coefficient of x, which is 1. What's our n? That's the degree. That's n. So far, so good. Are you trying to write everything down? Are you caught up? Probably not.
I just need the comment.
At least you're here today.
Yes. That's also, well, actually, no, that's not common. Not as common.
So if our degree is even and a is positive, that means our end behavior, the end of our graph looks like that. Both ends point up. If our degree is even, the exponent's even, and a is negative, then the ends of the graph point down. And right now, we don't know what happens in the middle. If the degree is odd and a is positive, that means as x gets bigger, it goes up. And you go opposite directions. If the degree is odd, they go opposite directions. And as x goes to infinity, because it's positive, it goes up. If n is odd and a is negative, it's a decreasing function. Again, we don't know what happens in the middle here. So in our example, our a is 1, our n is 2. So our graph will look like this. A is positive, n is even. So our graph will look something like this. Which means our lowest point is it a maximum or minimum? Minimum. So we have no maximum, and we have to find the minimum. The minimum is, in this case, it's our vertex. Remember how we found our vertex? How do we find our vertex? Negative b over 2a, and then plug that back into the equation to get the y value. So with this, what is our A, what is our B, and what is our C? Oop, I'm sorry. Right. A is the coefficient of x squared. That's A. It's 1. The coefficient of x is our B. The constant is our C. So now we just plug these in for this x value. For the x value, we have negative b over 2a. So it's negative 5 over 2 times 1. So that's the x value of our vertex, of our minimum point. What do we do with this number? Plug it back into the equation. So the probability, the polynomial at negative 5 over 2 is negative 5 over 2 squared plus 5 times 5 over 2 plus 6. And work it out. Negative 5 squared over 2 squared. Nothing cancels. So 5 times 5 is 25. 2 times 1 is 2. So negative 5 squared is 25. 2 squared is 4. So what do we have to do now? Everybody follow what I did here. Once I found the x, I plugged it in there. And I squared both the top and the bottom. I got positive 25 over 4. 5 times 5 is 25. 1 times 2 is 2. To go any further, I need to have a common denominator. What is my common denominator? 4. Because it can't, the LCD, least common denominator, cannot be smaller than the largest number. Because 4 goes into 4 once. Does 4 go into 2? So, but 2 goes up. We know our LCD is going to be 4. So in the middle one, I got to multiply top and bottom by 2. And the last one, I have to multiply by 4 over 4. 25 over 4. 50 over 4. 24/4. Now I just add the top. (99/4). Yes.
At the very beginning, when you over 1 times 5/2,
Mhm.
would you take out the negative?
Ah, good point.
Or would-
It would still be negative. You're right.
Oh.
Yes. So this one's still going to be negative. So it's going to be minus there.
So
So just that middle sign changes to negative, which makes it -50 plus 49/4, which is -1/4. Thank you. So this is my y value of my vertex. Yeah, I thought it was pretty weird for a second. Thank you for pointing out. Because x was -5/2, so I have to put -5/2 where there's an x. Thank you. So that's my y value. So it's going to be -1/4. So that is my minimum point. The minimum point will occur at this location because we know the graph opens up. So what's the domain? Yeah, all real numbers. In other words, it's from -infinity to +infinity. We can look at here because no x will violate the rules of math. What's the range going to be? What? Yep. Because it opens up, the lowest point we have here is at, on the x-axis, it's at -5/2, and the y-axis, it's -1/4. And it opens up. So our domain, or the range, is y is greater than or equal to -1/4. Okay, only thing we're missing are the x-intercepts and the zeros. How do we find those? To find the zeros, solve for x. In other words, set y equal to 0 and solve for x. So we have 0 equals x squared plus 5x plus 6. And last chapter, we learned 3 methods: complete the square, graphing, and quadratic formula. Actually, factoring, 4 methods. So let's try factoring first. What goes in the first space? X and X. Remember, what goes in the first space is what's in the middle. Since it's X, we know X and X go there. And that equals X squared. What signs go in there? Y. Very good. The second sign's a plus means they're both the same. They're both going to be the first sign. They're both going to be plus. Very good. What times what is 6? When you add them, you get 5. Yeah, 2 and 3 or 3 and 2, doesn't matter which ones. So there's the factored form. What do we do with these? It's called the zero product principle. Since we have two numbers, so we have A times B is equal to 0. That's this number times this number equals 0. So that means either A equals 0 or B equals 0 or they both equal 0. So we take both of these numbers and set them equal to 0. Why are these called zeros? Yes, but that's not what they're called zeros. These are my zeros. The reason they're called zeros, let's see what happens. If I take this number and plug it inside here, so then it goes to 0, right? So negative 2 squared is 4. 5 times negative 2 is negative 10 plus 6. That equals 0. It's called a 0 because if I plug it in the equation, it gives me a 0. See the connection here. This is important for later on in this chapter. We know that x equals negative 2 is a 0 because if I plug it in the equation, I get a 0. But this also tells us that x plus 2 is a factor. If this is a 0 and I go backwards, then these are my factors of this equation. In other words, if I give you the zeros, you can work backwards and tell me the polynomial. Whereas if I gave you x equals negative 2, x equals negative 3, you can work backwards. I'll give you these. You multiply them together, you give me that. So that's the connection of the both. Then that's going to be important later on in this chapter. So if those are my zeros, what are my x-intercepts? So my zeros are at negative 2 and negative 3. What are my x-intercepts? Negative 2 comma 0 and negative 3 comma 0. Very good. Because the x-intercepts are a location. They're a point. The zeros are values. Okay, let's see if it's sunk in what I just told you. What if my zeros, if my zeros were these, what can you tell me about the polynomial? What's the degree? Yeah, because the degree is the number of solutions. The number of solutions are my zeros or my x-intercepts. You see how these names are all the same? Solutions, zeros, x-intercepts. They're all finding appearance at the same locations, just written different. So find me the polynomial that has these zeros. What would you do? Well, since these are my zeros, I set them each to these. Let's work backwards. So let's make all of these equal 0 because they're my zeros. So x equals 0. I move this, I subtract 1 from both sides. So I have x minus 1 equals 0. I add 2, so I have x plus 2 equals 0. Since all of these equal 0, I can put them all together. And then multiply them together. Since we know it's a degree 3, it's going to be a cubic function. So let's multiply these together first and then multiply by x. X times x is x squared. Positive, positive. So we have 2x minus x minus 2. Combine like terms. So positive 2 minus 1 is positive 1x. And then distribute the first one. And there's my polynomial that had those values as zeros. So this is, I'm trying to put this in your head. You see how they're related? Normally, I'd give you something like this. The first thing you would do is what? Well, do they have anything in common? Can I factor anything out? They all have an x in common. So I can take out an x, which gives me this. Can I factor this one out? Yeah, I can go to here. X squared plus x minus 2 becomes this. Then I set each of these equal to 0, and this gives me my zeros, which is that. Or backwards, if I give you the zeros, work in reverse, and you get the polynomial. So far, so good. So now, we know the zeros were 0, 1, and negative 2. How do I know these are my zeros? If I plug those inside this equation, what's going to happen? Yeah, they should all equal 0 because they're zeros. So again, I'm trying to force something in your head now. So if I have a number and you plug it in there, it gives me 0. That means that this is a factor of my polynomial. If x equals 1, then I know that x minus 1, this is also a factor. This is where we're going in this chapter, but I just want to show it to you while it's still fresh in your heads. Does everybody have, oh, let me see, who doesn't have a sheet from last time? Uh-oh. May have run out. Yes, send over to you. I'll bring it next time. Oh, I remember, next Monday, I'll be here, but next Wednesday, the class will be virtual. will be online because I'll be in the conference in Vegas.
Is there like a Zoom link that?
Yes, I'm glad you asked. If you go to, okay, let me show you real quick here. If you go to our class, (13, 14) here. Let's pretend this is our class. And you go to the syllabus. There's syllabus. You go to the syllabus. It's right here. So, and that's if you ever want to meet with me online, same click. Or so that'll get you this Zoom site
That's
next Wednesday. All right. So let's look at now on your sheet. That's it. When I finish these, I'll give you these. Okay, I'll give you these when I finish. This is my last copy. So, polynomial functions. What do we notice about them? First off, they're continuous. Second, they have to be functions. How do we know it's a function? Vertical line test. Circles are not functions. So all of these pass the vertical line test. And they're smooth. Non-polynomial functions, if they have corners, if they have points, if they're not continuous throughout the entire domain, or if they have jump discontinuities, which means, yeah, it goes opposite directions. Like this graph here is the 1 over x type graph. They're still functions, but they're not polynomial functions. And here's some more. It's a continuous function. This is a polynomial. This is discontinuous. Why is this a discontinuous function? Yeah, because if I'm putting my pen here, I got to jump and put it up here. And I got to jump down, put it in there. The domain is negative infinity, positive infinity, but it's not continuous. It has what we call jump discontinuities. This one's not continuous because it has a hole in it. How do you get holes in a function? You get holes in a function. Let's say if we factor out the equation, we get this. If you can after you factor both top and bottom, and you can cancel something. So that value of x, whatever that number is, if we plug it back in there, at this value x, I have to put a hole. So it's a discontinuous function because, again, if you ever have to pick up your pencil or pen, it's not continuous. Leading term tests, that's what we just talked about. Remember, if the degree is even, what's the degree? Where do you find the degree? The largest exponent. If it's even, both ends point the same direction. If A is positive, they both point up. If A is the leading term is negative, they both point down. So if you look at this one, the leading term is negative x to the fourth. So it points down and they both point the same direction. The largest one here is negative x to the 10th. It's an even degree, so they both point the same direction. It points down. odd degrees, if it's positive, if the A is positive, then the right-hand side goes up, left side goes down. It's an increasing function. If A is negative, this is negative x to the fifth. If A is negative, opposite directions, but the right hand goes down. If the right hand goes down, the left side goes up because the degree is odd. At negative x to the seventh, again, it's an odd degree, which means the opposite directions. Since it's negative, the right side goes down, the left side goes up. 1/2 x to the ninth, again, odd power. And this is positive, so it goes up to the right, down to the left. If it's odd, they go opposite directions. So far, so good. And there's a cheat sheet again. Again, we don't know what happens in the middle because as the functions get larger, all we know are the end behaviors. These are what are called end behaviors. What happens to the end of the function? All right. Let's look at example 1. Let's use the leading term test to match the function with the graph. What I'm going to do is I'm not going to use those pictures. I'm going to put the equations here and let's sketch our own. So A is f of x equals 3x to the fourth minus 2x cubed plus 3. B, f of x is equal to negative 5x cubed minus x squared, 4x plus 2. X to the fifth plus 1/4 x plus 1. So let's look what these graphs will look like. When I look at the pictures that I gave you. So the first one, what can you tell me about the first one? Just by looking at this thing, what can you tell me? Yeah, because the degree is even, both ends point the same direction. Do they point up or down? Because 3 is positive, we know that both ends point up. Do we know anything else about this equation? The y-intercept, so the graph crosses at 3. And we know that has to be going up. Well, we don't know there, but we know the end behavior has to be going up. So out of these 4 graphs, which one has that possibility? Yeah. The only one that goes up both directions and crosses at 3 is D. So this first one has to be D. The second one, look at the leading term and the y-intercept. End behavior tells us what? Right. Because this is odd, we know we have either, it goes opposite directions. Since A is negative, it has to point down as x goes to infinity. And it has to cross the graph at y equals 2. So which graph is it? B, because the only one that goes opposite direction and crosses it too. So this one has to be B. The degree is 5, which tells us what? It's opposite directions. It's either going to be an increasing function or a decreasing function. A is it positive or negative? Positive. So it has to be going up. So it can't be this one. So it has to look like this. And it has to cross the y-axis at +1. So the graph points different directions going up to the right, crossing at 1. So which letter is it? A. This is only 4 choices, so we know what the last one. But let's look at this. It's an even degree, which means that either they both point up or they both point down. Since it's negative, which one is it? In other words, it has to be pointing down. What's my y-intercept? Is there a constant? So it crosses at 0. In other words, it crosses at the origin. Since there's no constant term, the y-intercept is 0. How do you find the y-intercept? Set x equals 0. 0, 0, 0. So this one has to be, both ends point down, has to cross through the origin, so it has to be C. So far, so good. So just by looking at the equation, we should have an idea what the graph's going to look like, what the end behavior is going to look like, what the direction. Now, finding zeros of polynomial functions. When we say finding zeros, what are we talking about? X-intercepts, or so when we're looking for zeros, we set the equation equal to 0. If you can factor it, great. If not, don't waste your time. Use the quadratic formula. Everybody remember that what that one is? Was for the quadratic formula, you always solve for the middle term. Yes. So it's x, it's a fraction, negative b plus or minus square root of b squared minus 4ac over 2a. Don't remember how to do the complete the square? Because that's how we get this formula. We start off with the general formula equation for polynomials or quadratics and use complete the square, and that's what we end up with. And actually, I'll show you that at the end of the semester when we have more free time. So in our case, let's go ahead and factor this if possible. So x and x. The signs are going to be what? They're opposite signs. Because the second sign's a minus. And the bigger number will go there because the first sign is negative. What times what equals 8? When I subtract them, I get 2. Four times 2 is 8. Again, that's the hardest part. Because you have to somebody should remind me Monday to bring, I'll give you all little multiplication cheat sheets. That'll make it much easier for you. Because this is the hardest part, simply because it's the multiplication process. So, since the first sign is a minus, the bigger number gets negative, so that's a 4, and that's a 2. So what are my zeros? Yeah, x equals -2, x equals +4. It's always going to be what's opposite inside there. And then, okay, let's look at example 2. Example, consider the polynomial x cubed plus x squared minus 17x plus 15. Determine whether 2 and -5 are zeros of p of x. So how would you do that? Plug them in there, see what happens. If the answer is 0, then it's a 0. 2 cubed, 2 squared, 17 times 2 plus 15, 8 plus 4 minus 34. Don't bobblehead. Do it yourself. Don't bobblehead. I want you to do it yourself. Because if you can't do this, then there's no way you can pass any other math course with another teacher. Remember, I'm letting y'all do it on your own honesty. If you don't understand this stuff and you have to cheat, don't ever put my name in there saying that if anybody asks you why you don't know math, tell them I cheated. Don't tell them because I took Professor Magala's class and I cheated. He didn't check my work. Just be honest and say, listen, I cheated. Yeah, I didn't care about my education. Eight plus 4. Get negative 22 plus 15. So it's not a 0. Then we do the same thing with the -5. -5 cubed, -5 squared, 17 times -5 minus 15. What is -5 cubed? Right. -125. -5 squared, 25. Negative and negative makes it a positive. 17 times 5. 7 times 5 is 35. 5 plus 3 is 8. So I can combine by commutative property, I can move them around. I can associate those numbers. So negative 125, negative 15 is negative 140. Twenty plus 80 is 100. It's 110.
The last 15 should be a plus.
It's constant. Oh, yeah, it should be plus, yeah. Yes. Okay. Thank you. Thank you. Yeah. So we have negative 125 plus 110, 125 is 0. So yes. Negative 5 is a 0. Which also tells us a little bit more. Since x equals negative 5 is a 0, that means x plus 5 is a factor of that answer. If you find the 0 of an equation, then you can find the factors of that equation. All right, let's look at example 3. Find the zeros. So since we know that we have 3x minus 2's, we can simplify the equation like this a little bit further. So my zeros are at x minus 2 equals 0, x plus 1 equals 0. These are where the graph crosses the x-axis. Those are my solutions, my zeros. What else can you tell me about this equation, this graph? If I asked you to sketch it, what would it look like? What's the degree? How many x's do we have? 1, 2, 3, 4. So the degree is 4. If we add the exponents, we get the degree. So since we know it's degree 4, what do we know about the end behavior? They both go the same direction, either up or down. Since all of the x's are positive and the coefficient's positive, that means we know that our graph will look something like this. What are my intercepts? At negative 1 and 2. Those are my zeros. Those are my intercepts. So I know from there, since it opens up, the graph will look something like this. Do I know anything else? Will the graph bounce or cross at these intercepts? At 2. Since the multiplicity is odd, it crosses. At negative 1, the multiplicity is odd, so it crosses. If it's even, it bounces. Do we know the y-intercept? So where does it cross the y-axis? Look at all the terms here. So -2 times -2 is +4, times -2 is -8, times 1 is -8, times 5 is -40. So it's going to cross, it'll look something like this, because it's all we know for sure. All we know for sure is that our x-intercepts and the y-intercept. The rest of the graph, we have to plot points. If we had our polynomial that looks like this, if we look like this, let's sketch this graph. What are my x-intercepts? 2 and -1. What's my degree? So we know they go opposite directions. Does it go up to the right or down to the right? Look at all the x's. That's a positive. That's a positive. That's a positive. So it's 5. So it's going positive. So it's going to go up here, and it's going to go down here. So our leading coefficient's positive. So far, so good. Now, since x minus 2 has an even, these are called multiplicities. Since it has an even multiplicity, that means it bounces at that point. At -1, it crosses. So the graph will look something like this. And what's my y-intercept? To find the y-intercept, just erase your x's. Just erase your x's. -2 squared is 4. So it crosses at 20. Let's look at example 4. G of x equals -x minus 1, x minus 1, x plus 2, x plus 2. We can combine all these because they're the same. So x minus 1, we have 2 of those. X plus 2, we have 2 of those. So what are my zeros? -2 and +1, right? It's always the opposite of what's inside the parentheses. If you don't see it, just set those equal to 0 and solve for x. So at -2 and at +1. What's the degree of the polynomial? degree is 4 because there's 1, 2, 3, 4 terms. There's 4 x's. So that means both ends point the same direction. Do they point up or down? Down, because leading everything is negative. So we know that at both ends, the graph is going to cross down. What's my y-intercept? Remember, to find the y-intercept, so we get rid of the x's. So we have -1, -1, 2, and 2. Negative, 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 so it's -4. So the only thing we know, what does it do at -2? Does it cross or bounce? They both bounce because their multiplicity is even. So the graph's going to look something like this. Or it can even be just like this. We just don't know what's going to happen there. We have to plot some points. Example 5. X cubed minus 2x squared minus x plus 18. Here we have 4 terms. We have a cubic equation. Find the zeros. In other words, we can't factor this the way we're used to because we're used to quadratic equations. So the first thing, if you have 4 terms, the first thing you would do is a method called grouping. Group the first 2 numbers together and group the second 2 terms together. Since the middle term is a minus, the middle sign's a minus, include it in the parenthesis. If it was a plus, then I won't have to. I can have a plus between them. Okay, so far so good? So grouping, put parentheses in the first 2 and last 2. Now factor. What do they have in common in the first one? X squared. So if I take out 2 x's, all I have left is x minus 2. How about the second one? What do they have in common? They both have a -9. You don't want to have, your first term doesn't want to be negative. So if I divide both of these by -9, what do I have left? X minus 2. What's that? Because whatever I factor out, I divide to see what's left. The 9's cancel the negatives, so I have x. Positive divided by negative is negative. 18 divided by 9 is 2. Now, what do both of these have in common? They both have an x minus 2. This one and this one. So if I take those out, what do I have left? The coefficients. Can we factor out this one? It's called the difference of 2 squares. Yeah. So we have x squared minus 3 squared. So that makes it x plus 3, x minus 3. And there's your factors. So what are my zeros? Mhm. 2, -3, and 3. And we can even graph it if you wanted to. The y-intercept is positive 18. It's the constant. We have our zeros at 2, 3, and -3. The end behavior says what? It's an odd degree. It's positive. So this side goes up, this side goes down. All of the factors have an odd multiplicity, so they all cross. So it'll look something like this. And the last example. Example 6. Okay, we're fortunate. It only has 3 terms. We're used to having equations with 3 terms that look like this. That's quadratic, right? Now, look at both of these. This is what we call quadratic in form. Because they look the same. How do we know? Look at the quadratic equation. The power of the middle one is 1, right? If we double it, we get the first one. If we take the middle times 2, do we get a 4? Yes. Because of that, it's quadratic in form. It has 3 terms, and it's the first x is twice the middle x. So we can factor or quadratic formula. But remember, you're always solving for that middle x. So we're going to have x squared, x squared. Even if we did the quadratic formula, we would solve for x squared. What's that? Yeah, then we have to square root it. Because when we square root this, you get a plus or minus. You get the 2 answers you're looking for. Because we have to have 4 answers. The second sign's a minus, so one's a plus, one's a minus. What times what is 4? When you subtract them, you get 4. Or what times what is 45? When you subtract them, you get 4. What's that? 5 times what? 9 times 5 is 45. 9 minus 5 is 4. So the bigger number gets the plus. So that's 9, and that's 5. So now we got to take both of these and set them equal to 0. So when we square root this one, we get x equals plus or minus what? Because you can't square root of negative. So it's plus minus 3i. And this one, you square root this, x equals plus or minus square root of 5. These are your four answers. So the last two, the grouping and quadratic and form, you have to be very careful about those. When you solve for quadratic and forms, it's always the middle term. I mean, I could even have x to the 8th plus 4x to the 4th. This is quadratic in form because if I double it, I get the first term. Yeah, you would solve for x to the 4th. You always solve for that middle. All right. Sorry I kept y'all later than I expected. I was hoping to do 2 sections today, but your questions were